Okay, our next presenter is Alison Post. She's a fifth-year PhD student in ecology, and she knew she wanted to study plant ecology when, as a child, she spent hours in the garden. And I think she was there playing her piccolo, because she also plays the piccolo. And with her degree, she hopes to research the impacts of climate change on ecological systems. The title of her presentation today is When It Rains, It Pours.
When it rains, it pours. While some of you might recognize that as the slogan for Morton Salt, you know, the one with the little girl and her umbrella, it also describes our climate reality. As a result of climate change, many parts of the world are experiencing fewer rain events and instead more frequent large rain events, or deluges. This has drastic consequences for many ecosystems worldwide. But because grasslands are particularly dry, they are very sensitive to any changes in rainfall pattern. Grasslands account for 30% of our world's land area, and they serve as habitat for animals, ranchland for cattle, and as a filter to remove carbon dioxide released by fossil fuels. Therefore, my research focuses on how deluges impact plant growth in a grassland ecosystem. Using field experiments, I water patches of the shortgrass prairie to simulate deluges of varying sizes across the growing season. This has already yielded several interesting results. First, the shortgrass prairie is extremely sensitive to the amount of rain that falls in a given deluge event. Now you might say, well, of course, if you water the grass more, it grows more. I know that from my lawn. But the striking part is that I couldn't water the grassland enough. The larger the rain event, the more the grass grew. I expected to eventually hit an upper limit where the plants couldn't use any more water, but I never hit that limit even when I applied a third of average yearly rainfall as a single rain event. Because of this enormous plant response, a single deluge has the ability to transform the shortgrass prairie from sparse brown to a healthy green, essentially rescuing it from drought. However, deluge timing also matters. A deluge that occurs in the middle of the summer causes much greater plant growth than a deluge that occurs of the same size in either early or late summer. All told, deluges are powerful. A single deluge has an impressive impact on plant growth in the shortgrass prairie. But the magnitude of that impact depends both on deluge size and timing. Our world is experiencing more frequent large rainstorms, but when predicting the ecological consequences of climate change, most current models only consider seasonal rainfall totals. My research exhibits the importance of also considering precipitation pattern, especially when it comes to deluges, because after all, when it rains, it pours, and when it pours, it matters. Thank you.